Welcome to this explainer. The internet operates a lot like a massive global logistics network. It's working tirelessly behind the scenes to route data across miles of fiber optic cables and airwaves straight to your screens. And today, we're going to look really closely at the delivery drivers of this digital highway, TCP and UDP.
It really begs the core question. How does all that data physically arrive at our devices perfectly intact and exactly on time? Because behind the seamless experience of streaming in 4K or firing off an instant message, there lies what is essentially organized chaos. And to actually manage all that chaos, we rely on some highly specialized transport services.
So here's our roadmap for today. First up, we'll cover the basics of internet transport services. Then we'll meet TCP, the reliable courier, followed by UDP, the speed demon. We'll put them head-to-head in a protocol showdown and wrap things up by figuring out exactly how to choose the right tool for the job.
All right, kicking things off with Section 1, Internet Transport Services, the delivery agents of the web.
The thing is, the internet doesn't just rely on a single, one-size-fits-all method for moving data around. Instead, it utilizes transport services. These are the systems entirely responsible for providing data delivery to your internet applications. The two main heavyweights here are TCP, which stands for Transmission Control Protocol, and UDP, or User Datagram Protocol. This is essentially a tale of two entirely different approaches. They both move data from point A to point B, sure, but their philosophies on how to do it couldn't be more different.
Let's dive into the first one. Section 2, TCP, the reliable courier. This is all about meticulous and careful data delivery.
If TCP were a real-life delivery driver, it would be the one carrying your most fragile, high-value items. It's what we call connection-oriented. That means before a single byte of actual data is transferred, it insists on a strict three-way handshake. The sender initiates, the receiver acknowledges, and the sender confirms. Only after that mutual agreement is fully established does the data actually start to flow. It's kind of like scheduling a strict delivery window and demanding a signature before the package even leaves the warehouse.
TCP absolutely guarantees reliable delivery, and it does this using acknowledgments. If the sender doesn't get a receipt back, boom, it retransmits. It constantly checks for errors to prevent any data corruption. It ensures ordered delivery by piecing all the packets back together sequentially, and it uses flow control alongside dynamic congestion control. That basically ensures it never overwhelms the receiver or clogs up the network. It literally leaves nothing to chance.
But, as you might guess, there is a catch for all this meticulous care. Because TCP has to constantly track sequence numbers, acknowledgments, and congestion data, TCP headers, those little informational tags attached to every single packet of data, are significantly larger. This introduces additional overhead. And more overhead means more processing power and more time. So consequently, TCP is generally slower. It's making a conscious trade-off, sacrificing sheer speed for absolute certainty.
Now let's flip the script. Section 3, UDP, the speed demon. It's reckless, but it is blazingly fast.
If TCP requires signatures in triplicate, UDP is the driver speeding past your house and just chucking the newspaper onto your lawn. UDP completely throws the rulebook out the window. It is totally connectionless. No polite handshakes here, it just blasts data packets out completely independently. There's no guaranteed ordered delivery, no flow or congestion control to speak of. And most importantly, it does not use acknowledgments. It really doesn't care if you actually received the data. It's already busy sending the next packet.
And that right there brings us to UDP's ultimate advantage. By completely stripping away all of those heavy reliability mechanisms, error checks, and acknowledgments, UDP has significantly smaller headers. Less overhead means way less processing time, which results in blazing fast data delivery compared to TCP. It is lean, it is mean, and it is built entirely for speed.
So let's put them in the ring together. Section 4, the protocol showdown, reliability versus speed.
When we actually set them head-to-head, the contrast is stark. On one side, we have TCP, highly reliable and perfectly ordered, but inherently slower due to all that administrative overhead. On the other side, UDP, highly unreliable but operating at incredible speeds. TCP meticulously checks every single box, while UDP doesn't even bother waiting for a signature. Two entirely different tools for entirely different jobs.
Which brings us nicely to Section 5, choosing the right tool and looking at real-world applications.
Look, because our daily digital activities demand entirely different priorities, we absolutely need both of these protocols. Think about it. When you're loading a website,
downloading a big file, or sending an important email, your main priority is data integrity. You need perfect reliability so those applications use TCP, just like downloading the data for this very explainer. But for live multiplayer gaming, streaming live video, or hopping on a VoIP call, your priority is speed. If you drop a frame or a tiny fraction of audio, you barely even notice. But if the app paused to go request old data, you'd experience massive, frustrating lag. Real-time apps need current data right now, so they choose UDP every time.
To summarize our core takeaway today, applications choose between TCP and UDP based entirely on their specific requirements. Neither protocol is inherently better or worse than the other. It is just a classic engineering trade-off. The choice simply comes down to what the application values more in any given moment: perfect, pristine data integrity or real-time, lightning-fast speed.
So I'll leave you with this final thought. The next time you experience a momentary stutter in an online video game, or you sit back and watch a massive file successfully download to your desktop without a single hitch, ask yourself, which internet delivery agent is hard at work behind the scenes right now? Is it the careful courier or the speed demon? Thank you so much for joining me in this explainer. Keep exploring the hidden architecture of your digital world.